In this video, we're going to go over the testing for common ions. So there are different tests for ions. One of the tests is through a flame test. You have also ions that can produce a gas. So we have a gas evolution test, and we have the precipitation test, which is the formation of a solid. Now let's start with the flame test. The flame test, it's a simple qualitative analysis method, and it's used to detect the presence of metal ions in the sample by observing the color of the flame. Now, some metal ions, they emit a characteristic color. It could be a red color, it could be blue, it could be violet. When it's heated, and this color can help identify the metal ion present in the substance. Now, how is the flame test carried? First, we have to put a clean platinum or nichrome wire should first be cleaned by dipping it into a hydrochloric acid solution. And then we need to heat the wire in a clean flame from a Bunsen burner until it burns without any color. This ensures that no previous samples affect the test result. After doing this, we need to dip the clean wire into the sample. It could be, for example, let's say a solution containing, let's say, lithium chloride or NaCl, and then we place it into the flame, and then we should observe the color change as the sample is heated. So let's go over ions that produce a flame color. The first one is lithium ion. So a lithium ion will produce a red flame, crimson red flame, which is a deep rich shade of red. The K plus potassium ion gives a lilac flame, or we can say a purple flame, a violet. Na plus, which is the sodium ion, will give a yellow orange flame, and Cu2 plus, copper 2 ion, will give a blue green flame. We also have the barium ion, Ba2 plus, which gives a pale green flame. The Ca2 plus, which gives a brick red flame, which is a medium to dark reddish brown color. Now let's go over the ions that when they react with certain substances, they produce characteristic gases that can help in their identification, and we refer to these as the gas evolution tests. The first one is the ammonium ion. Upon the addition of NaOH and when we warm gently, where a pungent smelling gas is going to be produced, and this gas is called ammonia. And ammonia turns red litmus paper into blue. And this is the equation that will take place that will lead to the formation of NH3, which is a pungent smelling gas. The second one is NO3 minus, which is the nitrate ion. We will use aluminum foil, for example, aluminum powder with NaOH, and we will warm gently. And we will also have the pungent smelling gas that we mentioned earlier, which is the ammonia gas, NH3. And the equation is not required because it's a complex reaction. Then we have the SO3 minus, which is the sulfite ion. The reagents that we're going to use are nitric acid. So we're going to add dilute acid like nitric acid, and we will observe effervescence. The SO2 gas is going to be formed. And since it is an acidic gas, it turns wet blue litmus paper into red. So it's the opposite as in the case of ammonia. And SO2 also has a choking smell. And this is the equation that will lead to the formation of SO2. Going to CO3 minus, which is the carbonate ion. So the reagents that we will use are a dilute acid of like hydrochloric acid or nitric acid, and we're going to observe effervescence and fizzing. And the effervescence or fizzing indicate the release of the CO2 gas. Now, to make sure it is the CO2 gas, we pass the gas over lime water, which is a calcium hydroxide solution. And if we pass it through this solution, then it's going to become milky, which indicate that the gas is carbon dioxide. This is the reaction of the carbonate ion with the H+, which will lead to the formation of CO2. And if we pass the CO2 through the lime water, then we're going to have the CaCO3 solid with water. Now, a note that if this gas is passed through lime water for a long time, the milkiness can dissolve and it's going to go away, and the solution becomes clear again. Now we're going to go over the precipitation test. And the precipitation test involves adding a reagent to the solution to form an insoluble solid, a solid that does not dissolve anymore. And this can help us identify the ion that is present. So the first one that produces a precipitate is the sulfate ion. So to identify if it's a sulfate ion, we add barium nitrate followed by dilute acid HCl or nitric acid. We will observe a white precipitate that does not dissolve in the acid. Or we can say over here, instead of saying all this, we can say sometimes acidified uh, barium nitrate. And this is the reaction that will take place, and it will lead to the formation of barium sulfate, which is a white precipitate. Now, just a note, we acidify the solution. We add HCl or HNO3 to make sure there's no CO3 minus carbonate ion or sulfite ion that's present. Because if a carbonate ion or a sulfite ion is present, then they will not precipitate in an acidified reagent. So the only ion that will precipitate with barium nitrate when it's acidified is the SO4 minus. This is why we acidify the barium nitrate. Now going over the group 7 ions, which are Cl minus, Br minus, and I minus, the halide ions, starting with the chloride ion, bromide, and iodide. Now these three, we add the same reagent for the three of them. We're going to use acidified silver nitrate, and we use an acid to exclude the hydroxide precipitate with silver nitrate solution. So we acidify the AgNO3 to make sure that there is no OH minus with present in the solution, in order to remove the OH minus, and so that no precipitate is formed with the hydroxide ion, OH minus, and Ag plus. So for the Cl minus, we're going to observe a white precipitate that's formed, which upon exposure to light turns white then black. So for Cl minus with silver nitrate, we will have a white precipitate, and this is the reaction. For the Br minus, we're going to have a cream precipitate, and this is the reaction. For the I minus, we're going to have a yellow precipitate, and this is the reaction that will take place and lead to the formation of the precipitate. Going over the Ca2 plus, Al3 plus, and Zn2 plus. Now, what's confusing about them is that they all give a white precipitate, and you have to be careful with these ions. Now, we start with the Ca2 plus. One way to identify which white precipitate it is by knowing if it dissolves in excess NaOH or not, or if it dissolves in excess ammonia, NH3, aqueous, or not. So starting with Ca2 plus, it will form a white precipitate with sodium hydroxide, but it will not dissolve in excess. So if we add more NaOH, the precipitate with the white precipitate will not dissolve. And with NH3, there will be no reaction, no precipitate that's formed. The equation for the formation of the precipitate over here is this reaction, which will lead to the formation of calcium hydroxide, which is a white precipitate. For the aluminum ion, whenever you hear the word it's gelatinous, then this means that it's the aluminum ion. It's a white gelatinous precipitate that dissolves in excess NaOH, unlike unlike Ca2+, which doesn't dissolve in excess NaOH. With NH3, when we add it to Al3 plus, a solution containing Al3 plus, we will have a white gelatinous precipitate that does not dissolve in excess NH3, and this is the reaction. For Zn2 plus, we will also have a white precipitate that dissolves in excess NaOH. So both of them dissolve in excess NaOH, whereas Zn2 plus dissolves also in excess ammonia. However, the Al3 plus does not dissolve in excess ammonia. This is a way to differentiate between them, in case if they didn't mention it's a gelatinous. And this is the reaction that takes place when we add NH3 or NaOH to the Zn2 plus. We're going to form the zinc hydroxide. And as we said, the three of them have a white precipitate color. Now, one thing about aluminum is that if they mention it's gelatinous, then we can know that it's definitely aluminum. Now for the Pb2 plus, Ag plus, and Ba2 plus, they also, all of them, they will form a white precipitate. for Pb2 plus, if we add HCl, Cl minus, it will form a white precipitate, and this is the reaction that will take place. For Ag plus, actually, we went over it before, and we said it's actually the reverse, which is Cl minus. Adding it to Ag plus will give a white precipitate. And over here, I included it in order to remember that you can also know silver ion by using, let's say, a Cl minus. You can also know it by using a Br minus or an I minus, and they will give a specific color. Now with Cl minus, it's going to give the white precipitate that we mentioned before. For Ba2 plus, if you add SO4 minus, and this is also mentioned before when we talked about the SO4 minus, where we have the SO4 minus, adding it to Ba2 plus will form a white precipitate, and I just included it over here so that you can know that the barium can be identified vice versa by using the solution containing SO4 minus, like sodium sulfate, where a white precipitate will also form, and this is the reaction that will take place. Now, Fe2 plus and Cr3 plus are somehow confusing because they both give a green precipitate. The only way to differentiate between them is by knowing which one dissolve in excess NaOH and excess NH3 or not. So these two are also confusing. The Fe2 plus will give a green precipitate that does not dissolve in excess NaOH, and it also gives a green precipitate with ammonia, and it also does not dissolve with the excess NH3. And this is the reaction taking place that will lead to the formation of the green precipitate. Now for the Cr3 plus, you're also going to have a green precipitate that dissolves in excess NaOH. So this one will dissolve in excess, and this one will not dissolve in excess NH3. So one way to know which one, if it's a green precipitate that does not dissolve in excess NaOH, then it's Fe2 plus. If it dissolves in excess NaOH and it's a green, then it's Cr3 plus. And this is the reaction of Cr3 plus with the hydroxide ion. The final two are Cu2 plus and Fe3 plus. Now Cu2 plus is easy to remember. It's the ion that will give a blue precipitate with NaOH or NH3. So the Cu2 plus will give a blue precipitate that does not dissolve in excess NaOH. However, if you add NH3 ammonia to the Cu2 plus, the blue precipitate is formed that dissolves in excess NH3 and is going to form a deep blue solution. So if you add Cu2 plus, you're going to have the blue color over here. If you add to it a solution containing NH3, then you're going to get this color over here. And this is the reaction that you need to remember with Cu2 plus. Now for Fe3 plus, the iron 3 ion, you're going to have a red-brown precipitate that does not dissolve in excess NaOH, and you're also going to have a red-brown precipitate form that does not dissolve even in excess NH3. This is the color, and this is the reaction. And you also need to know that for Cu2 plus, it does not dissolve in excess NaOH. However, it dissolves in excess NH3.